Welcome to the series of videos on household circuits. So in this video we're going to talk about how AC current comes to home. We're going to try to get a big picture here. So first we have the local power station, and the power station typically it produces electricity using generators at about 11 kilovolt. So that's the voltage that it generates, and typically it will be at 50 hertz in India, and depending upon the power of this generating station. So let's say this is a 110 megawatt generator. Your current would be power divided by the voltage. That's about 11 kilovolt, and that will be about 10 power 4 amperes. That's a lot of current that's getting generated here. Now once this current that gets generated at 11 kilovolt, this is stepped up. So this is a step up transformer. This is a step up transformer, and this is stepped up to about 132 kilovolt, and this we call it as your grid substation. So the grid is a national power lines that pass across various states. We call that these grid lines. Those are about 132 kilovolt. And the reason why we do that is because as we know that as we increase the voltage, so as your voltage is increased by a factor of, let's say here from 11 to 132 is a factor of 12, we know that the transmission current will reduce by a factor of 12. So because of this, our power loss in the transmission due to transmission is given by I squared R. So your power would go down, your power loss would go down by, since this is I squared, your power loss would go down by 1 by 12 squared, right? So that's a loss, that's a lot of saving of the power loss, right? So here the power doesn't lose too much. And to ensure that ensure the power loss is minimum, the other thing that we do is we minimize the resistance. So this is R is less. And how do we do that? By having thick wires. So when you have very thick wires, so this is thick wires used for high voltage transmission. So since we're carrying it for long distance, so we use very thick wires to reduce the resistance, to reduce the power loss, and we are also trying to increase the voltage for the same reason, to reduce the power loss. So once we do this, we transmit the current, and it reaches the main substation, and these substation are local substation of local towns. Like for example, near Bangalore, we have in Bangalore, near our school, we have in a location called Tataguni, you have this substation. There's one at Kanakpura. Near all industrial places there will be a substation, and these substations bring down from 132 kilovolt to either 33 kilovolt or 11 kilovolt. It depends on what is the use. If it is for commercial, commercial or industrial area, you have 33 kilovolt. But if you have it for domestic or like a township, etc., that's brought down to about 11 kilovolt. So once we do that, we pass this 11 kilovolt to another substation, and this substation is what we call it as a city substation. So this is what you find outside your home. So here your 11 kilovolt is further brought down to 220 volts, and finally it reaches your home. So here's what happens. Here's a summary of what happens. So you're generating, your generation is at 11 kilovolt. Your grid substation is 132 kilovolt, and then your main substation, it brings it down to, so this is a step up, so this one brings it down to about 33 or 11 kilovolt. We call it, it's a main substation or the intermediate substation. And finally the city substation brings it to about 220 volts. That's in India. If it is in US, it's going down to about 110 volts and not 220 volts. That's why in adapters you see that, you know, this voltage specification is sometimes 110 volts to 220 volts. Okay, I hope you enjoy this video. In the next video, we're going to look at how this power comes from or current comes from the city substation to your home, and how do you consume it. See you in the next one.